Hey guys, this video is going to be on our midterm review free response question, and it's question 49 from chapter 4. Okay, so let's get started. Immediately, this question is basically asking or saying that there's some guy over here, and he throws a ball 1 meter off the ground at angle theta, and it has to clear this house here, which is 6 meters high, because they give us this 45-degree angle, and you already know it's 3 meters, and you want your friend over here to catch it again at 1 meter, or at a height of 1 meter. So the very first thing I'm going to do is I'm going to split up the problem into 2 sections. So I think it would be easiest to split it up right here, because you know whatever happens in this first part is going to happen in the second, since it's a parabola. It's projectile motion. So what I'm going to say is, I'm going to go ahead and say my velocity final y squared is going to equal velocity initial y squared plus 2 acceleration y delta y. Okay, and from this equation, I know that my velocity, so velocity final y, my velocity at the very top here, since it's a parabola, it's going to stop, so that's going to be 0. I want to find out my velocity initial y squared. I know my acceleration in the y direction is only going to come from gravity, so that's negative 9.8 meters per second squared. And then my delta y, so this value right here, a lot of people are going to say that it's 6, but I want to make it extremely clear that it is not 6 meters, because although the house is 6 meters tall, you're going to start throwing it from 1 meter high. So you're going to have to do, so this height right here is what you're looking for. The 6 would be the whole thing. So you're going to do 6 minus 1. So that's 5 meters. Okay, and if you solve for velocity initial y, you should get that it equals 9.90 meters per second. Okay, perfect. Now what I'm going to do is I'm going to work on the second half of the problem. So I'm going to go ahead and, actually I don't even have to work on the second half, because first I want to find out how many seconds it takes to get to the top. So in order to do that, I'm going to say so use another kinematic equation. It's going to be y final equals y initial plus velocity initial y t plus 1/2 ay t squared. Okay, and in this equation I'm going to fill in some stuff that I know. So I'm going to start here at 0 and go up till 5. So I'm going to say 5 equals 0 plus, I know this value now, so it's 9.90 t minus 1/2 9.8 t squared. And if you solve for this, you're going to get t equals, I think it's, 2.02 seconds. Okay, I have my velocity initial y, and I have my time. So now all I'm going to do is try to solve for my velocity initial x. And how I'm going to do that is, you know that the total distance that the ball has to travel is this 6 plus this 6 plus this 6. So it's 18, right? So I'm actually going to write, so another kinematic equation is x final equals x initial plus velocity initial x t plus 1/2 ax t squared. And you know that this is projectile motion, so once it takes off, your acceleration in the x direction is 0, so you can cross that value out, and that evens out to 0. So this x final, I'm going to subtract the x initial over, and you get delta x, which you know now equals 18. So I'm going to write this as 18 meters is going to equal velocity initial x times, and I know my time, it's 2.02 seconds. Right? Yeah, 2.02. Oh, and real quick, just so there's no confusion, I got this 2.2. If you take this value and if you solve it yourself, you're going to get time equals 1.01 seconds. But I just simplified it because you have to take this whole value and multiply by 2, right? Because that's the time that this ball is going to take to go from here to here. But you want the total time, so the whole parabola. So it's going to be the exact same, right? Because the amount of time it takes to get to the top is the same amount of time it's going to take to go from the top to bottom. So I multiplied that by 2 in order to get this 2.02, just to make things clear. And yeah, okay. And then you're going to get your velocity initial x is going to equal 8.91 meters per second. Okay, now that I know my velocity initial x and y, I can find theta, right? Because I know my theta, or tangent of theta, right? So tangent is going to be opposite over adjacent, so it's going to equal my velocity initial y over velocity initial x, and I'm going to get theta going to equal to 48 degrees. So just plug that into your calculator and you should get that. So I got one part of my problem done, and the last part, I want my total launch velocity, right? So since I know my components, I can use the Pythagorean theorem and just square both the components to get my final. So velocity initial x squared plus velocity initial y squared, and that should give me a total initial velocity. So total is going to equal 13.3 meters per second. And that is problem number 49.